Hi everyone, welcome back to Nuskit. So let's solve today's daily LeetCode challenge, which is merge in between linked list. So let's try to read the problem statement first. So we are given two linked lists, list 1 and list 2 of size n and m respectively. Remove list 1's nodes from the 8th node to the bth node and put list 2 in their place. The blue edges and nodes in the following figure indicates the result. So let's say for example, we are given this list 1 and this is the list 2. And now we will be given some node number, let's say A to B. So what we have to do is we need to remove all of these nodes from A till B, and in place of this, what we have to do, we will connect this node to the head of the list 2, right? And the last node of the list 2 needs to be connected with this particular node, right? Which would be the next of the node which we have to remove. So now let's look at this example. So this is list 1, this is list 2, and this is the output that we are expecting. Let's see how we are getting this output. So we are given that we need to start removing nodes from index 3 up till 5, right? So if I number this, so 0, 1, 2, 3, 4, 5, 6, 7 and 8. That means we will start removing nodes from here up till here. So eventually what will happen? All these 3 nodes will be removed, and this 8 will connect to this 10, right? And this 40 will connect to this 4. That means that 3, 6, 8. Now we will cut this point and we will make sure that 8 will start pointing to the head of the list 2. And similarly, 40 was earlier pointing to null. So we will make sure that instead of pointing it to null, we will make sure that this 40 will start pointing to this 4. And eventually what will happen? The next of 8 will become 10 and the next of 40 will become 4, right? And this would be our output, and then we will return this list 1 as an answer. So I hope you understood the problem statement. Now let's see how we can actually solve it. This is a very simple problem. Okay, so let's look at this. So what we'll do, we will take 2 pointers. One will be the start and another pointer will be the end, right? Okay, and end is pointing to the this particular node, right? Let's say end is pointing to this first node. Now what will I do? I'll basically run a loop, right? So I'll run a loop from I is equals to 0 to less than equal to 5, right? Let's see that. And as soon as my I will match to the 2, as soon as my I will match to 2, I will stop, right? Why I would stop at I is equals to 2? Let me make it clear, right? Say for example, if you are at here, but to connect this remaining linked list with this list 2, we need the pointer which is behind this 2, right? So that is why rather than stopping at index number 3, I will try to stop at one index prior to that, right? I hope this is making sense, because to connect this list, I need one pointer back, like one previous pointer, okay? Because if you are at 2, right? Let's say if you are at 2, you cannot really access this 8 pointer because you will need to connect this 8 to 10, right? So if you are at this 2, you will not be able to do that. So we need to make sure that we stop one pointer behind this 2, okay? Great. So this is why I will run a loop from 0 till 5. And as soon as I will encounter I is equals to 2, I will stop. Okay, great. Now let's see. So what will happen? I will start running my loop. Okay, great. And initially my I is 0, which is fine. And at this point in time, I is not really pointing to 2. So I'll make sure that I'll move to the next. Great. And now my I will become actually 1. So I was initially 0. Now I has become 1. Great. This is a running loop, right? Nice. So now once again I'll check if my I is pointing to 2. No, I is not pointing to that. Not pointing to 2. That means once again move your pointer and to the next. So and we will increment this. Like this will be incremented. So now at this point in time I will become actually 2. And once again when I will try to move forward, I will first check whether I has become a minus 1. Because I has become a minus 1. That means I can make sure that this is gonna be start pointer, right? This will be my start pointer. Okay. So which means as of at this point in time, I now know that 8 needs to be connected to the list 2, right? But make sure you continue to running your loop, right? And make sure that you reach till this 5, right? Unless like for I is equals to 5 also, you need to run this loop. Great. So now I is still less than equal to 5. So once again, you will take your pointer and you will increment it. Now I will become actually 3. Once again, I is still less than equal to 5. So make sure you once again run a loop. So end will be incremented, and once again your I now will become 4, and 4 is still less than equal to 5, which means that make sure that you once again increment your end, and at this point in time I will become 5, but 5 is still less than equal to 5, which means you can still move forward. So once again move forward, and finally what happened? You have come to this node number 4, which means that you have crossed all those nodes which needs to be removed, right? Because we really don't need them now. So once this loop is ended, now what you need to do is make sure you write this thing. So what we'll do, we'll say start dot next is equals to list2, right? So by doing so, we are making sure that we are connecting this 8 to this 10, right? Great. So now we have connected this 8 to this 10, which eventually means that we are kind of breaking this pointer. Now, if I ask you what is the next of 8, so the next of 8 is not actually 2, but the next of 8 is actually 10, right? Great. Now what will happen? You now need to iterate on this particular list and make sure that you reach to the last, right? So how can I reach the last node? So I would simply say, okay, let me just make some space. So I would simply say that while list2.next is not equals to null, I will simply keep moving forward. So list2 will become list2.next, right? So now let's make list2, this is the pointer list2, right? So now list2.next is not equals to null, which means I can move forward. So I'll simply move forward. Again, list2.next is not equals to null. So once again, I will move forward. Again, list2.next is not equals to null. I will move forward. And at this point in time, list2.next is not equals to null, but it is null, right? So which means I will stop over here, right? So once I reach over here, now it's very simple. What you can do is now you can say list2.next is equals to end, which means that you are making sure that now you are pointing to this node, to this end node. And now once again, you are breaking this particular pointer, right? So let me just summarize this question, what we did. So first, what we did is we run a loop. Which is I is equals to 0 to I is less than equal to 5. And we were saying that at any moment, if I becomes equal to a minus 1, I will say that my start will become the current pointer, because end is my current pointer, which is moving from the very first node till the last node, right? And at the same time, like I'll keep incrementing this end is equals to end dot next. Okay. So once I will set this start, and end will completely move till this less than equal to 5, right? This is not like less than equal to 5, but it would be like b, less than equal to b. Second was, okay, once you do this, make sure that you are saying that start dot next is equals to list2, right? So you are moving the first node of this list1 to the head of the list2, right? Great. Which means now you have broken this particular link. Now as a third step, we are making sure that now you reach the end pointer of this list2. You need to make sure that you reach over here, because end is already pointing over here, right? So these are the nodes in between, and then end is over here. Okay. So now you make sure you need to make sure that you reach from here till here in the list2. So you will simply say, okay, while list.next is not equals to null, you are making sure that list2 is equals to list2.next. This is what you need to do. This is list2, right? And once you reach over here, you need to make sure that you will say list2.next is end. Okay. So as a fourth step, what you need to do is list2.next is equals to end. And then we can return list1, right? Because list1 is still pointing over here. So now rather than your list1, rather than being this, you are basically, your list has become this actually. Okay, great. So let's try to code this quickly, because it's very simple. So what I'm saying is, that we will take two pointers, list node start and end will be pointing to list1, right? And let's make sure that start is pointing to, let's say, null as of now. Now I will run a loop. So for int I is equals to 0, I is less than equal to b, and I plus plus, and I'll say if at any moment I becomes equal to a minus 1, right? So I'll say, okay, this current end pointer will become my end. Otherwise, I'll simply making sure that end is equals to end dot next, right? Now, once this is done, now we need to make sure that, okay, start dot next is equals to list2. Okay. So now we have pointed this 13 to this head of the list2. And now I'll need to make sure that I need to reach to the end of the list2. So for that, I can simply run a loop. So until this is not equals to null, I'll keep saying that list2 just move forward, list2.next. Okay. And once you reach to the end of the list2, we will say, okay, list2.next is equals to end, and then we can return list1, and then we can return list1. Let's try to run this. and I hope it should run. So we are getting, okay, so this is semicolon, sorry. Now let's try to run this once again, and it is accepted. Now let's try to submit this, and it got accepted. So this is it, and the time and space complexity for this problem is m plus n, because in the worst case scenario we are iterating over this list and we are iterating over this list. So it will be m plus n, where m and n are the length of respective linked lists, right? And the space complexity is big often because we are really not taking any extra space, right? We are making changes in the existing linked lists. So this is it from my side for this video, and I'll see you in the next video. Till then, bye bye.